This video covers examples having to do with angle pair relationships. And the examples answer the essential question, how are special angle pairs identified and used? So a series of questions to go along with this diagram here. What kind of angles are 2 and 3? If you look at 2 and 3, there's nothing special about these angles because the two rays that create angle 2 and 3 are not collinear. They're not opposite rays. You can see this is clearly not an opposite ray for this side. So 2 and 3 are nothing special. Same diagram. What about angles 3 and 4? 3 and 4 share a side. Share this side here, and they also have sides that are opposite rays, so that's going to make them a linear pair. Same diagram. What about 1 and 3? Again, because this non-opposite ray sides, there's nothing special about angles 1 and 3, even though they might look vertical. Same with 2 and 4. They're in position that might be vertical, but because, again, these sides of the angles are not opposite rays, there's nothing special about angles 2 and 4. Here's a diagram from an example. Angle 6 in the diagram has a measure of 130 degrees. Find the measures of the other 3 angles. One way to start out is looking at the relationship between angles 6 and 7. They're linear pairs, so we know that the sum of their measurements is going to add up to 180 degrees. We know that measure of angle 6 is 130. With a little bit of subtraction, angle 7 has a measurement of 50 degrees. Well, angles 5 and 6 are also a linear pair, so if we know that angle 7 had a measurement of 50, we know that angle 5 must also have a measurement of 50 degrees. And 5 and 7 are vertical angles, so we know that their measurements have to be the same. And lastly, the measurement of angle 8 as a vertical angle to measure 6 must be 130 degrees also. Okay, given the diagram below with expressions involving x and y as the measurements of these given angles, solve for x and y. There's a few different approaches you can take with this, but probably the simplest is going to be that angle AED right here and angle DEB are a linear pair. So the measurement of angle AED plus the measurement of angle DEB should be 180. So we can take the expression 3x plus 5, add that to the expression x plus 15, and we should get 180 when we solve for x. So 4x plus 20 is 180. 4x equals 160. X is 40. Okay, likewise, we know that angle AEC right here and angle CEB right here are a linear pair. So we can take the expressions y plus 20, which is the measurement of angle AEC, plus 4y minus 15, which is the measurement of angle CEB, and those should add to 180 also. So that's 5y plus 5 equals 180, 5y equals 175, and y is equal to 35. So x is 40 and y is 35. Now how about finding the measures of each of the angles in the drawing? Well, if we know that x is 40 and y is 35, we can substitute those values in. The measurement of angle AED will then be 125 degrees. The measurement of angle DEB should be 55. Now those should also be the same measurement of the other angles because of the relationship between the vertical angles. AEC is vertical with DEB, also 55 degrees, and angle CEB is a vertical angle to AED, also 125 degrees. So here's a clock showing, one clock is showing the time of 4 o'clock, and the other, this is 4 o'clock, and the other clock is showing a time of 10 o'clock. Oops, 10 o'clock. And the question is, state whether the two angles are complementary, supplementary, or neither. Well, how do we know the measurement of an angle on a clock? Well, each hour of a clock corresponds to 1/12, since there's 12 hours around the clock, 1/12 of a full circle, which is 360 degrees in it. So 1/12 of 360 degrees is 30. So each hour has 30 degrees. So for the 4 o'clock hour, this angle in here, the angle here can be represented by 120 degrees. That's 4 hours times 30. 4 times 30 is 120 degrees. And for the 10 o'clock, we're going to measure the acute angle here, which is really, there's 2 hours from 10 till noon, or 10 till midnight, 10 till 12. So those 2 hours at 30 degrees will make an angle of 60 degrees. So the 4 o'clock clock is showing 120 degrees. The 10 o'clock clock is showing an angle of 60 degrees. And the sum of the two angles is 180 degrees, therefore they are supplementary. Question, what's the complement to a 47-degree angle? Complementary angles add to 90 degrees, so 90 minus 47 gets us 43. How about the supplement to a 75-degree angle? Supplementary angles add up to 180, so 180 minus 75 is how we find its supplement, and that's 105. What angle is its own supplement? So that would be an angle that is, if we double it, we get 180 degrees, or in other words, half of 180 degrees. 90 degrees is a right angle. Angle W and angle Z are complementary. The measure of angle Z is 5 times the measure of angle W. Find the measure of angle W. Well, if these two angles are complementary, we know that they'll add to 90 degrees. We can rewrite measure of angle Z by substituting in 5 times the measure of angle W. And if we substitute that into our first equation and combine like terms, we'll have 6 times the measure of angle W equals 90 degrees. That tells us W must measure 15 degrees. If an angle is 28 less than 3 times its supplement, what is the angle? Well, an angle, let's call it A, is 28 less than 3 times its supplement. Well, we'll call it supplement S. So 3S minus 28. So an angle A is 28 less than 3 times its supplement. Here's an equation. The relationship between A and S is that they're supplementary, so they must add to 180 degrees. This tells me that A is 180 minus S. So now I can take this equation this expression for A and this expression for A, and solve for S. Well, let me back up. How about maybe we can solve for A quicker if we set, if we set S equal to 180 minus A. That'll be a quicker way to solve. That'll take this expression, 180 minus A, and allow us to substitute it into this equation here, and then we can solve for A more directly. So A is equal to 3S. Instead of S, we'll have 180 minus A minus 28. Distribute the 3, and A is equal to 540 minus 3A minus 28. Add the 3A to the other side. 4A is equal to 540 minus 28 is 512, so the angle is 128. Okay, the complement of an angle is 12 less than twice the angle, so the complement of an angle is 12 less than twice the angle. So we'll say C is the complement, A is the angle. We know that the complement plus the angle add to 90 degrees. That's why they're complementary. So let's find the complement. What we want to do is solve for A right here. A is 90 minus C, and then we can take this 90 minus C and substitute it right in here. This is one way to solve. So C is equal to 2 times 90 minus C, and it's 12. Distribute your 2. C is equal to 180 minus 2C minus 12. Add the 3C to both sides. Add the 2C to both sides. We'll get 3C is equal to 168. Dividing by 3 gets us a complement of 56.